Right, let's see if I can manage to get full marks on this in 50 minutes. In my defense, I'm also going to be explaining the questions as I go along, so I might run a little bit over. Right. Let's get started. Okay, so the first question has a triangle. It's not a right angle triangle, so I'm certainly not going to be using SOHCAHTOA on it, but I can use the sine rule and the cosine rule on this. It's asking me to find this side AC. And I know an angle and an opposite side. So I know this pair here. I know this angle, and I'm looking for this side. So those things tell me that this is going to be a sine rule question. So I'm just going to write out the sine rule. And so I am going to call this angle A and this side A. So sine 35 over 10 equals sine 80 over the side I'm looking for, AC. And then I can use NSolve to solve that. So calculate. I just checked my my calculator's in degrees because the question's in degrees. All of yours will be in degrees. So if it ever says rad up here, make sure you swap it across to degrees. Then I'm going to go to menu, oops, not number, algebra. There we go, numerical solve. I'm going to type in my equation so I can get the fraction up by using that. And then here are the trig functions. So sine of 35, close brackets, over 10 equals sine of 80, close the brackets. I forgot to put in my fraction. Hopefully I can get it now. Yeah, it's okay. Over, and I'm just going to call it x. And then I just need to put in the comma and the x to tell it that that's my variable and close the final brackets. Once I've got it looking like that, I can press enter. And the solution it gives me is 17.169599 and so on. But I'm going to round this to 3 significant figures, which is 17.2. The next question asks me to find the area of this triangle instead. And there's a formula in the formula book to find that area. And that is a half AB sine C. And the key thing to remember is that this angle here must be between those two sides. So I know this side. I have just calculated this side. So this is the angle that I must use within that formula. And that angle, if I figure it out, it's going to be 180 minus 80 minus 35, which is 65 degrees. So I can fill out this formula now, and it's going to be a half times 10 times, and here is where a lot of people manage to lose 1 mark, because when you're carrying on working with a figure, it should be the unrounded figure that you use, not the rounded figure. So for me, I'm going to use the ANS button in my calculator, which I'll show you in a moment. But you should be multiplying it by 1.76, sorry, attempt number 3, 17.169599 and so on, sine of 65. So when I type that into my calculator, it's a half, it's easier for me to type in 0.5 times 10 times, and because that value is the one I've just used previously, I can press Control and then ANS, and then it will just use the full thing in there, and then sine of 65. Close the brackets, hit enter. Oh, it's not happy with that, is it? Hang on a second. I think it's the ANS followed by the sign that it's not happy with. And now I've lost my ANS. Oh well. 0.5 times 10 times, and now I'm going to write it all out instead, 17.1699, 5992129. There we go. And then sine 65. Close brackets. You know what? Maybe it wanted a multiply there as well. Now I think about it. Can't do any harm to add in an extra multiply. There we go. And then that gives me the final solution of 77.8. If you used the rounded figure, you'd have 77.9, and you would have lost 1 mark on this question. Right. The next question is about box plots. It first asks for the longest amount of time spent on homework per day, and that is this value on the box plot. So it's going to be 300. And then the second one, it asks the interquartile range, and I know the interquartile range is Q3 minus Q1. Here is Q3. Here is Q1. So it's going to be 220 minus 100, which is 120 is my interquartile range. It then asks us to state the statistical term corresponding to the value of 140 minutes. So that corresponds to this line here, and that is the median on a box plot. It's kind of like the second quartile, and it makes sense because if this is the lower quartile and the upper quartile, those are calculated by using the median. Right. It then asks us to find the percentage of students who spend between 100 and 140 minutes per day on their homework. So I'm just going to take a look here, and 100 was my lower quartile and 140 is my median. And these values, they already tell us the percentages, because between the minimum value and the lower quartile, that is 25% of your data. Between the lower quartile and the median is another 25% of your data. From here to here, 25% of your data. And from the upper quartile to the maximum, 25% of your data. Remember, that's kind of the definition of the quartiles, is that they're kind of markers of each quarter of the data. So when it asks what percentage are between 100 and 140, that's going to be 25%. And then more than 100 is all of this up till here, and so that's going to be 75%. Right. So we have a straight line equation. It's asking us to find the gradient and the y-intercept of that equation. Now, I'm going to show you an algebraic way to do it, but I'm also going to show you a way to do it on your calculator, because I think, you know, not everyone feels confident with rearranging formulas algebraically, but that's not to say that you couldn't do a question like this. So our issue with this equation is it's not in the y equals mx plus c form right now. So it's not easy to read straight off here what the gradient and y-intercept are. So the algebraic way to solve this is to rearrange that equation to say y equals. And the first thing I'd do is move that x across to the other side. So I'd have 2y equals 10 minus x. And then divide everything through by 2. So I'd have y equals 5 minus a half x. And then when it's in that form, the number in front of the x is our gradient, and the number by itself is the y-intercept. So that means our gradient is minus a half, and our y-intercept is 5. So as long as you're happy doing that rearranging, that's probably the quickest method to do it. But let me show you a calculator method too, because your calculator is so handy, and I want to make sure you guys are using it the best you can. So what I can do is go into the graphing part of my calculator. Let's start a new one. I don't need to save that. Add a graph. Perfect. And our issue here is this is in the f of x form. It wants a function, it wants a y equals, and we don't have a y equals. But remember, you can go into the graph entry and change it from a function to a relation. And then you can type in whatever you like. So I'm going to type in x plus 2y equals, there we go, 10. And then I've got my straight line equation there. I don't want to lose it. There we go. And it is something I only mentioned once or twice quite a long time ago, but we can find the gradient of a straight line by using menu, analyze graph, and then this is the one you're looking for. So remember, gradient is change in y over change in x, and dy over dx, we'll get into it more later, but it's basically saying change in y over change in x. So if I select that, it's saying, where do you want to find this gradient? Well, actually, to be honest, for us, it doesn't really matter because the gradient of a straight line is the same everywhere. So I might as well pick there. And look, it's telling me that the gradient is -1/2, which is the value I've already found. And I can also find the y-intercept here if I go for, analyze graph won't help us here. So it can find intersections with other lines. It can find the x-intercept, so that 0 tells you the x-intercept, but it won't help us find the y-intercept. But trace is pretty handy for that. So in fact, the first thing I think it comes up with is where the y-intercept is. So if I just click there, I can't really see it because it's overlapping with my function, so I can just click. Can I click and drag? Well, you can pretty much see it 0, 5 there. So our y-intercept is 5. Right. The next question says L2 is parallel to L1 and passes through the point 0, 3, and it wants the equation of L2. So we know it's a straight line, so it's going to be in the form y equals mx plus c. If it's parallel to L1, then what we're saying is it's got the same gradient as L1, so I can take my gradient from the previous question, -1/2, and fill that in. So now I've got y equals -1/2x plus c. And then the plus c is the y-intercept. But if I take a look at this, 0, 3, if I kind of plot that as a point, 0 on the x-axis, 3 on the y-axis. So actually that value was already a y-intercept. So that means that my c is going to be 3. So y equals -1/2x plus 3. The final question says, find the x-coordinate of the point where L2 crosses the x-axis. You've got two options here. When it crosses the x-axis, y is equal to 0. So you could substitute in y is equal to 0 into that equation that you've got above and solve that. So if I bring the 3 across, then I have -3 equals -1/2x. And if I divide through by -1/2, I've got x equals 6. Ooh, 6 equals 6. Well, that's true, but not very helpful. X equals 6. Or alternative option, if you don't feel confident about substituting in a value and solving it, I can also use the calculator to solve this. So if I go to menu, graph entry, I'll go for a function this time because it is in the form y equals. So y equals -1/2x plus 3, enter. And that was that second line that popped up here. I want to know where it crosses the x-axis. So if I go to menu, analyze graph, and it's a 0. So 0 is where it crosses the x-axis. I want the 0 of this graph. And it's asking me just to say where's just before this 0. There's just before that 0. There is just after it. And then it tells me that that coordinate there is 6, 0. So again, I have x equals 6 there. Right, next question. Assume the Earth is a perfect sphere with radius 6,371 kilometers. Calculate the volume of the Earth. Give your answer in that form. We'll get around to this later, but for now, in the formula book is the formula for the volume of a sphere, which is 4/3 pi r cubed. My radius is given to us, so I'm just going to type that in. So 4/3 times pi times 6371 cubed. And if we go to the calculate part, I can type that in. So I want the fraction 4/3. Pi is down here. And then I'm just going to put that in brackets so I don't accidentally end up cubing everything. 6371 to the power of 3. There we go. Oh, I don't want my bracket up there. Let me just click out of that. There we go. Enter. This looks like a bit of a mess, but remember, you can press Control and Enter and it gives you a decimal answer. Now, lots of you saw this and a few of you wrote down, I think you missed this part where it said E12 there, and so you just wrote down like 1.08 and some change, but 3 significant figures, so 1.08. Some people left it like that because they didn't notice this E12 there. For those of you that did, some of you understood what it meant and others didn't. So the E12 is already saying it's times 10 to the power of 12. And in essence, what that means is to get the real value, you would move the decimal point this way 12 times. Because obviously this is going to be a really large value. So make sure you're sense checking your answers, because for the people who said, oh, the answer is 1.08, that doesn't make a lot of sense, because if you're going to cube 6,000 and something, it should definitely be bigger than 1.08. So just watch out for that. So that's the final answer. Right, the next question, I'm going to struggle to show you this all at once, but I was struggling to get set up for this. So we've got a cumulative frequency graph. Here's our monthly income. Here's our cumulative frequency, the number of families. So the first question says, find the median monthly income. Now the median monthly income is when we're halfway through our frequency. Our total frequency is 2000. So our kind of median frequency is 1000, but that's not the final answer. I need to come along to the graph, come down again, and this value here is my median, which is going to be 2,500. There we go. Then it says, write down the number of families who have a monthly income of $2,000 or less. So here is $2,000. I now I know my monthly income and I want to know my number of families. So I come up to here and then along, and that value is 500. Then it says, find the number of families who have a monthly income of more than $4,000. And you need to watch out here, because the nature of a cumulative frequency graph is it shows you that value or less. It doesn't automatically show you for more than $4,000. So let's take a look at how we can find that. Here's $4,000. First, I am just going to go up on my graph to here, and then read along to here. I need to think carefully about what that value is. So I notice that each big gap is 250, and there's 10 little squares in between. So each little square counts as 25. So that's an extra 1, 2, 4 lots of 25 is 100. So that value is 1,850. But if I say 1,850, that is how many people had a monthly income of 4,000 or below. So I want kind of the other side of that. I want the difference between 1,850 and 2,000, which is 150. So make sure you write down your working, because then if you make a mistake, I was able to give a mark if I saw 1,850. But it's going to be 2,000 minus 1,850, which is 150. Right. The next question says the 2,000 families live in 2 different types of housing. The following table gives information about the number of families living in each type of housing and their monthly incomes. So there's either an apartment or a villa, and there's this many people who live in an apartment who earn between those amounts, this many people who live in a villa who earn between those amounts, and so on and so forth. And the first thing it asks us to do is to find the value of P. Now, this takes a particular level of conceptual understanding, right? Because otherwise you'd be like, where am I going to find this value of P from? But if we think about this, all 2,000 families should be listed in here. And these are frequencies, so these are our 2,000 families. So that P is kind of what would be left to make this up to 2,000. So the way I can calculate that is by doing 2,000 minus everything else. So 436 plus 64. I'm just taking my time so I don't make a mistake. Plus 765 plus 28 plus 122. There we go. And that gives me that what's left over to make it up to 2,000 is 585. Right. The final question says, estimate the mean monthly income for families living in a villa. So here are the families living in a villa, these ones here, and we want to estimate their mean monthly income. Now, it says estimate because we've got a range of values here. So the first thing we do when we're working out an estimate from a frequency table is we just have to take the midpoint of each of these. We can't calculate it with that full range. The midpoint of here is 1,500. The midpoint of 2,000 and 4,000 is 3,000. And the midpoint of 4,000 and 5,000 is 4,500. And then the usual way to calculate a mean from a frequency table, well, I'll show you how to do it by hand, but I'll also in a moment show you how to do it on the calculator as well. So we do 1,500 times by the frequency, which is 64, plus 3,000 times by the frequency, which was P. So, why am I writing it up here? Oh, well, I'm committed now. 585 plus 4,500 times 122. And then be careful here, definitely don't divide by 3. You want to divide by your total frequency, which is these 3 added together. So 64 plus P plus 122. And you can type that all into your calculator and figure it out. I'll show you how to do that first. So let me get that fraction in there nice and early because it's slightly easier. So 1,500 times 64 plus 3,000 times 585 plus 4,500 times 122. And on the bottom here, 64 plus 585 plus 122. There we go. It's got a fraction there, but it'll be easier for me if it's a decimal. So Control and Enter to get that. And I have 3,112.8. But to 3 significant figures, that's 3,110. Right. Let me now show you how to do this on the calculator. So we go into the spreadsheet part because we want to kind of enter it as a table. Up here, I'm going to put maybe income. It's hard to type in when it's not like a QWERTY keyboard. Right, and then the incomes are, you still got to find the mid-interval, that part I can't take out of your hands. So 1,500, 3,000, 4,500. And then we put in the frequencies. We call that, where's the R gone? I'll just call it freq, to save some time. And then it was 64, 585, and 122. And now I can come, there we go, back up to here and go to menu, statistics, stats calculations. This is one variable because there is only one variable, which is income. Frequency does not count as a variable. Number of lists 1, because there's only one list of data. And then my X list is income. My frequency, oh no, that's annoying. Hang on a sec, I just need to come along somewhere different. Let me try again. I accidentally put it through with the frequency being 1. Right, statistics, stats calculations, one variable statistics. Let me try again. Income, frequency list is freak. There we go. And results column H, hopefully that works out okay. There we go, that looks better. And what you'll notice is X bar is the mean. So 3112.8, which is what I had over here. So it gives you the exact same value. So if you're concerned about kind of how to figure all of that out, you can just put the table into the calculator for yourself instead. Right, next question. This question was nice and easy. It just asks you to find the gradient between A and E. So we can use the coordinates up here, so A and E, and it's rise over run, change in Y over change in X. So my change in Y is 3 minus 1 over 7 minus 3, which is, you know what, I'll just work this out. What is that? 2 over 4. So it's a half. So that's my gradient of AE. And that's actually setting us up for the next question. So the next question says, actually, you know what? We never read the context. Let's quickly read the context rather than me just finding out the gradient. So it says those points represent snow shelters in the Blackburn National Forest. I feel like that might be in England. Anyway, there's snow shelters in a forest. These snow shelters are illustrated in the following coordinate axes. Each unit on here represents 1 kilometre. Okay, important to know. Right, then as we turn over, we can see that the park ranger has drawn 3 straight lines to form an incomplete Voronoi diagram. And it asks us to find the equation of the final line for the Voronoi diagram to kind of cut off where site E is. So I'm just going to focus in on E here. And I can see there's a straight line going between E and B, so that one's been completed. There's a straight line between E and C, so that one's been completed. A straight line between E and D, the perpendicular bisect has been done. But the part we are missing is a straight line, which would look, so it should go perpendicular between those two. I don't know exactly what it looks like, but it looks maybe something like that. That's not phenomenal. Oh well. That's the kind of straight line we're looking for. And what I know is this straight line is the perpendicular bisector of AE. So if it's perpendicular to AE, then my perpendicular gradient for this straight line is going to be the negative reciprocal of the gradient between A and E, which we already know. So the gradient between A and E is a half. The reciprocal of that is 2, and I want the negative reciprocal, so it'll be -2. So the gradient is -2. It's going to be a straight line, so it's going to be in the form y equals mx plus c. I know what m is, it's -2, and I'm trying to find the c. But to be able to find that c, I need to know at least one point that this line goes through. And the point that line definitely goes through is the midpoint between A and E. That's the thing we know about perpendicular bisectors. So my next step is to find the midpoint of A and E. Let's take a look at what A and E are, but remember, to find the midpoint, I add together the x-axis, x coordinates of A and E and divide it by 2. I add together the y coordinates of A and E and divide it by 2. I find the average point. So if we take a look at this, so it's 3 and 7, and 1 and 3. So my midpoint, 3 plus 7 is 10, divided by 2 is 5. 1 plus 3 is 4, divided by 2 is 2. So this is the coordinate that I know definitely lies on this line. And so what I can do is substitute this coordinate into this equation to find my c. So the 5 is my x coordinate, the 2 is my y coordinate. So I have 2 equals -2 times 5 plus c. So 2 equals -10 plus c. And I could use nsolve, but it's nice and easy to solve. I can bring that 10 across, and I've got 12 equals c. So my final equation then for that straight line is going to be y equals -2x plus 12. Except I'm not done yet, because it's asking for it in the form ax plus by plus d equals 0, where a, b, and d are integers. So I want to take all of this across to the other side, so that equals 0. So I take -2x across, and that becomes +2x. I have my y, and that +12 becomes a -12, and it all equals 0. And then what are my a, b, and d then? I don't need to write these down separately, but my a is 2. My b is, well, I can't see anything there, but that means that's 1y. And my d is -12. And each of those numbers are integers, they are whole numbers, so I'm all done now. Right. The final question, a really good, interesting question, is in the context of the question, explain the significance of the Voronoi cell containing site E. So, site E, that's this area here, that is all of the points which are closest to E than they are to all the other points. But what was E? E was a snow shelter, right? So basically that area is the area that's closest to E out of all the different sites. So the area that is closest to the snow shelter E. Then maybe closer to the snow shelter E than the other sites, the other snow shelters. That's really the definition of a Voronoi diagram at all. Right, next question. Oh, final one. So, this question's saying, find the sum of all integers between 10 and 200 that are divisible by 7. Here's what I would do in this situation. It's a tough question, right? It's the final question on the paper. It's not meant to be easy. So there's no chance you're just going to look at this and straight away know what the answer is. So instead, what's your technique? How can you deal with that? The way I would deal with it is I'd start to write out, what is it I'm actually looking for here? Well, I'm looking for the sum, so I'm adding together the numbers between 10 and 200 that are divisible by 7. So let me just start writing that out. So the first number above 10 that's divisible by 7 is 14. The next number is 21, then 28, and I'm adding these together, right? And I keep going until I get to, I don't know, is it 200? I'm not sure. So I'm just going to double check that. Let me go back to calculate. There we go. And I'm going to try, can I divide 200 by 7? It doesn't look like it. No, that's a decimal answer. Let me try 199 divided by 7 then. Nope. 198 divided by 7. That gives me a fraction, probably not. 197 divided by 7. Nope. 196 divided by 7. Yes, then it gives me the answer 28. So I know my final number in this list is going to be 196. And now when I take a look at that, I can start to get the feeling that this should be the sum of an arithmetic sequence, right? Now I can see it written out like that. It wasn't obvious to begin with, but now it feels more like it. And I know my formula for the sum of an arithmetic sequence is Sn equals n over 2 times u1 plus n minus 1 times d. Right, what do I know already? I know my u1 is 14. Plus n minus 1, I don't know what that is yet. And d, my common difference, well, that's 7, right? There's a 7 difference between each of them. Then I need to figure out what n is. What number term in the sequence is this? How many jumps are there between 14 and 196? And I can do that by doing 196 minus 14. There we go, so that's the difference between them. And then I can divide that by 7. That's how big each of my jumps is. And it tells me that it's 26. So if this is the first term, that's the second term, the third term, I'm going to have 26 jumps to get to this one. But be careful because it's 1 jump to get to the second term, 2 jumps to get to the third term. So if I'm going to have 26 jumps, that makes this the 27th term. I could also do it by using the UN formula backwards, but that seems a bit like overkill, to be honest with you. So that means my n is 27, so now I can figure that out. 27 over 2 times 14, plus 27 minus 1 times 7. Give me a moment while I type that into my calculator. So 27 over 2, open brackets, 2 times 14, plus 27 minus 1. Oh, I lost my 1. Times by 7, close brackets. Have I closed enough brackets? I think so. Yeah, there we go. So when I've added that all together, it's 2,835. Part 2 then says, express the above sum using sigma notation. Oh, I like that. So sigma notation, here's my sigma. And at the bottom I write down, where did I start adding my sequence? So I started adding my sequence from the first term, so n equals 1. And where did I end adding my sequence? I ended adding my sequence at the 27th term, so it should be a 27 up here. And then next to that, I need to write my UN formula. What was I adding up? I was adding up UN. And the formula for UN is U1 plus n minus 1 times d, right? And my U1 was 14. The n minus 1 I'm going to leave there because I'm adding up all of these different n's. And my d, my common difference, was 7. So that's going to be 14 plus 7n minus 7. 14 minus 7 is 7. So it's 7 plus 7n. So that is what I'm going to write here. 7 plus 7n. So I've answered all of part A. The next question says, an arithmetic sequence has the first term 1,000 and a common difference of minus 6. The sum of the first n terms of this sequence is negative. Find the least value of n. When I read that, that sounds weird to me, because if I've got a positive first term, how can I have a negative sum? But then I think to myself, actually, if I'm minusing 6 each time, eventually it's going to become a negative sequence, and if I carry on adding on the negatives long enough, yeah, okay, the entire sum could become negative as well. So as I work this through, let's have a think. Let me first just write out my SN formula for this. So my SN formula, n over 2, I don't know what the n is, that's what it's asking me to find. 2 times u1 is 1,000, plus n minus 1, I don't know that, but I do know that my d is minus 6. And I would like this to be negative. Now, that's not easy to just say, go from negative to what I need to do next, but negative is when it becomes less than 0, right? So I want the sum to be less than 0, and that's what I'm going to work with. Here's the thing, your calculator can't solve an inequality for you, it can only solve an equality. So I'm going to type this into nsolve in my calculator, but rather than having the less than, I'm going to use an equal sign instead with my calculator. So, menu, algebra, numerical solve, and then I have n over 2, open brackets, 2 times 1,000 plus open brackets n minus 1 close brackets times, and because it's a negative number, I'm just going to put it in brackets to be on the safe side. I close my bracket again, and then I need to do a comma and an n to say that's what my variable is. Oh, that's not happy, is it? Let me take a look back. The first argument of nsolve must be an equation in a single... Oh, you know what I did. Oh, this is what you guys do all the time. I never know how to get back into this. I'm sure one of you does. Can I get back? I think I can. Anyway, I forgot to put my equal sign in there. I forgot to say it was equal to anything. nsolve can't solve something unless it's an equation. Let me try again. Right, algebra, numerical solve. My apologies. N divided by 2. Oops. Open brackets, 2 times 1,000 plus n minus 1 times minus 6. I'm just going to go back and put the multiply in there just in case. I don't think it'll make a difference, but I don't have a problem again. And then I close my brackets. And here's the bit where I went wrong last time. I need to put an equals and 0. And then I can do my comma and my n, close the bracket, and hopefully this time, what is going wrong? It definitely shouldn't equal 0. Oh, it's because, okay, here's the downfall of nsolve. When there's more than one solution, it will give you the lowest one. And actually, this can be solved when n equals 0, except that doesn't make sense in our context, or another value. So, it's a level 7 question. It's not meant to be easy. When this equals 0, either n over 2 equals 0, which gives us a solution of n equals 0, which is what the calculator's telling us, or the rest of this bracket equals 0. So you know what, I think I'm just going to work it through by hand. That looks easy at this point. So what we're saying is 2 times 1,000, so 2,000 minus 6n plus 6. That's what needs to equal 0. Or you know what, if I'm doing it by hand and don't need to keep the calculator happy, that needs to be less than 0. So 2006 minus 6n is less than 0. I can add on that 6n, so 2006 is less than 6n. Divide through by the 6, so 2006 divided by 6, which gives me 334.3 is less than n. So n needs to be greater than 334.3 for our sum of the sequence to be less than 0. The only thing to consider here is n must be a whole number because n is a term number. So that is how I can get my final answer of 335. There we go.